So first of all, in describing relationships in Chapter 3, there's two new types of variables. There's explanatory variables, and there's response variables. And the way it works is that the explanatory variable helps explain the change in the response variable. And the response measures the outcome of the study. And the easiest way to start thinking of it is something where we're going to feed the mice. Maybe we'll feed the mice candy. And then we're going to record weight gain of the mice. So feeding the mice would be the thing that we're going to be doing. The explanatory variable. And the response, what happens, and what we're going to be measuring is their weight gain. And it doesn't have to be something that, like for this one, probably the more candy you feed them, the more they'll gain weight. But it doesn't always have to be a positive correlation, and we'll talk about that next. So what we're going to end up having for these ones are two variables. So it's not going to be appropriate to do like a histogram or a bar graph or a what other things were we doing? Dot plot. These were all measuring one variable. These ones that we're going to be doing from now on, or for this chapter, are going to be two variables. They might be dependent on each other, but the way that we're going to be measuring two variables or looking at them is with a scatter plot. And if you've looked at a scatter plot before, there's a few different ways where you can look at it. Sometimes the dots will be all over the place, and there won't really be any type of correlation or any type of relationship that we can say. Then there's some that look like that, and there's some, and this is when we plot the data. It will look something like this. When we look at these, we're going to be talking about the direction, typically, and the strength. So for this one, there's really no direction, and it's not very strong. When you're looking at this one, notice it's increasing. So it's a positive association. This would be like feeding the mice candy and then gaining weight. The more candy you feed them, the more weight they would gain. That would be the type of what you would expect for this. And the strength would be, for looking at this, to me this looks really like a strong correlation. How close the points are following this line, going straight up. For this one, it would be a negative association. It's going downward. And again, it's like this strong relationship. Let me show you a couple others. So something that looks like this, and I'm hoping all these dots are going to be showing up with this pen, but we'll find out. The direction. So if you look at it, it does kind of look like it's going up. I'm trying to like draw a line in that would fit perfectly like through the middle of the dots. So there's an equal amount above and below. To me, it looks like it's a positive association. But I would probably say the strength of this would be like a moderate relationship. Let's see. Something like this. Maybe we'll put it. Something like this. More of a negative association. And this kind of looks like a weak relationship. And more of these all kind of look like lines to me. This one kind of looks more curved to me. So that makes it more of a weak relationship as well. One thing about these is outliers affect your outcome. So imagine if you had a few outliers on this one up here that were way up here, something like that. It would 100% skew this data a little bit more positive, more of a steeper slope. So outliers do affect the outcome of what occurs. So the last thing that we're going to talk about is correlation, which is lowercase r. And this actually gives a number measurement to the direction and the strength. Of the linear relationship. between two variables. So if we flip back to the back page and look at these 5 little examples that I gave you, for the first one where there's like no direction, no strength to it, it would have a correlation of probably 0. Something that has a real strong relationship would probably have something closer to 1, like 0.95 or something like that. Strong negative relationship would be negative 0.95. The highest you can go is 1, and that would be perfect, makes a perfect line. And the lowest you can go is negative 1, which would make a perfect negative sloped line. For the first one that we had here, without putting these 2 outliers on, this one might be a relationship of maybe 0.7. And something like this might be negative because it's going kind of downward, but maybe a 0.2. And where these numbers are coming from is there is a formula that's based on the z-scores, and it's made up of, and I'm not going to write it because I don't want to confuse you, but it's made up of the z-score of the x times the z-score of the y value added to the next x and y value, and so on. And it's kind of the average, so then you would actually and divide by the number you have minus 1, that degree of freedom. To recap, it's going to be a number between negative 1 and positive 1. And you can actually calculate this on a calculator.